Okay, so we're going to talk about completing the square, which is a strategy for solving quadratic equations. Before we dive into that, let's talk about what we know about quadratic equations, which is there are easy ones that can be solved using square roots. So for example, if your equation is x squared equals 9, that means that either x equals 3 or x equals negative 3. If you've got something a little bit more complicated, like maybe x minus 2 squared equals 9, that means that the thing in parentheses, x minus 2, is equal to either 3 or negative 3, which is going to mean that in this case, x can be either 5 or negative 1. So the example we're going to use for completing the square, we're going to start off with x squared plus 6x equals 7, which right now cannot be solved by square roots because you've got an x that's being squared and then you've got another x that's sort of just going rogue there, doing its own thing, and that's a problem. So our goal is to turn this into something that looks like something in parentheses squared equals a number so that we can take a square root. We're going to start off by thinking of x squared plus 6x as the area of a rectangle as shown here. So this rectangle has one side having length x and the other side having length x plus 6 to get a total area of x squared plus 6x. The total area here is also equal to 7 because our equation is x squared plus 6x equals 7. This rectangle right now is not a square. But we do know that squares have all the sides the same length. So what we're going to do is we're going to take that 6x chunk, cut it in half, and swing half of it down to the other side so that we've got two sides that are the same length. So then we've got x squared plus 3x plus 3x in this weird L shape. And we've got sides of length x plus 3 and x plus 3, but there's a piece missing. So what we're going to do is we're literally just going to fill in that missing piece to complete the square. And that missing piece has an area of 9 because 3 times 3 is 9. So this square that we've drawn now has an area of x squared plus 6x plus 9, which is also equal to 7 plus 9, adding 9 to both sides of our original equation. X squared plus 6x plus 9 is the same as x plus 3 squared, which you could get either by factoring or by looking at that square that we drew and seeing that both sides have side length x plus 3. And 7 plus 9 is 16. So we've got x plus 3 squared equals 16, which gets us x plus 3 equals 4, or x plus 3 equals negative 4, which then gets us x equals 1 or x equals negative 7. And that's our final answer. So those are the two solutions to that equation that we started off with. In this case, we got two rational solutions. So if you know how to solve by factoring, you totally could have done this by factoring and it would have worked out fine. But this strategy also works if the solutions are irrational. If we had had x plus 3 squared equals some other number that's not a perfect square, we would have gotten a square root when we square rooted it. It would have been an irrational number, and that's totally fine. This strategy works for solving any quadratic equation as long as you're able to follow these steps and you know what you're doing when solving by square roots.